Hey guys, so in this video we'll cover concepts around streaming and how to perform some basic operations with the streams. So what is streaming? Streaming involves breaking a resource down into chunks so we can process it bit by bit. Say we want to receive a large file over a network. So streaming APIs allows us to interact with the file in chunks so that we don't have to wait for the entire file to be available before trying to process it. So let's look at some examples with code to understand the concepts better. So I have a simple Node Express server setup. I am also serving some static files from the public directory, which includes the HTML file, JS file and some .txt assets. The UI looks something like this. I have 4 buttons and every time I am going to click any button, I am always going to fire the main function in index.js file. Each button corresponds to different examples that we are going to cover. So let's look at the first example. In this example, we are going to fetch a large file from server and read it chunk by chunk using the stream APIs. So let's look at the code. I have this fetch API call and I am passing the file URL to it. Once we get the response, let's look at the response.body in the console. I have also throttled the network so we don't get responses instantaneously. So we can see that the response body is of the type readable stream. Usually we don't interact with this readable stream directly, but rather we use methods such as response.text or response.json to get our data. Internally, these methods parse the entire stream themselves, process the chunk and then return us the data. In our case, we want to manually read the stream ourselves. So let's see how we can do that. Let's first get the stream object from the response body. In order to read the stream, we need to get the reader from stream by calling the getReader method. And once we have the reader, we simply have to call reader.read method on it to get our chunk. Let's see how this chunk looks like. So we get an object with property done and value. Currently done is false and the value is unsigned 8-bit integer array. So this is a special type of array called as typed array, and using this we can interact with binary data in array format. If we look at the values, we can see that these are UTF-8 encoded values of the character in the text file. If you look at the text file, so actually I have random characters inside it, but if we compare the first 3 characters, that is ABC, and compare the first 3 values in array, we can see that they correctly correspond to the UTF-8 encodings, that is 97, 98, 99. These are also same as ASCII values, as I have only alphabet and special characters in my text file, and UTF-8 is backward compatible with ASCII. If you want to know more about this special array, you can refer to typed arrays, data views and array buffers in the WebMDN docs. So since these are encoded values, the next thing that we have to do is decode them, and we do that using the text decoder. I already have a decode text method here. I am declaring the text decoder object. So by default, text decoder assumes that we have UTF-8 encoding, so we don't need to pass anything special. And in the decode text, I am calling the .decode method. Let's see if we get the chunk correctly. So yeah, we get the first chunk from our text file. Now if we want to get the next chunk, we simply call the .reader method again. So yeah, this is the second chunk. So the best way to do this is a while loop, and we will repeatedly keep on calling the read method on the reader. The done property will ultimately change to true after we have finished parsing the stream. Here I am updating the inner text of a div with our chunks, but it will happen fast anyways. Let's throttle a bit more as we don't want to update the DOM too frequently. So we see all the chunks, and yeah, we have finished parsing the entire file. There's one more way we can read a stream, and that is using the for await loop. So since readable stream is of the type async iterable, we can use this particular syntax. Also, we have to get rid of the earlier code as we can't read a finished stream again. So let's look at this. So it's the same result, just that the syntax is a bit simple. So this is how we can manually parse the response body ourselves and read data chunk by chunk. One important thing here is that we don't have any control over the chunk that we get from the response body. It is automatically handled by the fetch API. Next, we are going to look at how we can create readable stream ourselves on the server, add chunks to it, and stream it to the client. In this example, we are going to refer to the /streaming route to create our readable stream. We have this getStream method. So let's implement it. Firstly, let's create a new readable stream object. One thing that I want to add here is that Node.js has its own native API for interacting with stream. And if you want to create a Node.js readable stream, we do that using the readable class. And if you want to create a web stream, we use the readable stream class. Web streams can be used across both client as well as server. They are a web standard. In this video, we are only going to focus on web streams. The good thing about Node.js is that we can easily convert between a web stream and a Node stream. So let's add some data to our stream. And we do that using the start method available in the constructor. The readable stream internally maintains a queue, and whenever we want to add data to that queue, we simply call controller.enqueue method. So let's add a chunk to our queue. The start method is fired as soon as we create a readable stream object. Now we want to send this readable stream to our client, and we do that using the pipe2 method available on the readable stream object. It is used whenever we want to send data from a source to a destination writable stream. In our case, the writable stream will be the response object, but the response object is of the type node writable stream. So we have to first convert it into a web writable stream, and we do that by calling the toWeb method. So this is how we send the stream data from the server. Now let's receive it on the client. On the client, we'll be using the same logic for the rest of our examples. That is, we'll be calling the fetch API and we'll be passing the routes, the ID for which will be passed from the respective button clicks. So we'll get the stream from the response body, we'll get the reader, and then we'll start reading the stream. The only difference from the previous example is that instead of using a while true or for await loop syntax, we are recursively calling the read method to parse our chunks. Let's also console log the chunk and see how it looks on the browser. So we successfully see our chunk. Now there are two things to note here. First is that even after sending our chunk, we still get done as false, and the reason for it is we have not closed our stream. So we need to call the close method on our controller to indicate that we are done sending the data. So let's see if we get done as true now. So yeah, let's try adding one more chunk. Enqueue chunk 2. So we get the chunk 1 and chunk 2 successfully. But if you see in the response, we receive a single chunk. That is the combined value of chunk and chunk 2. And the reason for that is the way fetch API works. Fetch API internally has its buffer, and it tries to fetch maximum data possible from the server. In this case, our chunk 1 and chunk 2 combined. And then it creates a readable stream which is available in the response body and adds a chunk with whatever data it has in the buffer. That's why we see the chunk 1 and chunk 2 as combined. If we had read the readable stream on the server itself, we would have gotten the chunk 1 and chunk 2 separately. Let's try doing one more thing. Let's add a for loop and iterate up to 50. Let's add the chunks, add the I, add the new line. Let's delete this, and after adding every chunk, let's wait up to 100 milliseconds, and since this is asynchronous, we had to add the async keyword. Let's look at how it looks on the browser. So we can see that in this particular response, we are getting separate chunks for each particular chunk that we added on the server. And the reason for that is the fetch API will have to add whatever it has in the buffer, and at the time it has only one chunk since we are waiting every 100 milliseconds. So that's the reason why we get separate chunks in the stream from the fetch API. Okay, so let's move on to how we can tee a stream. So what is teeing? Teeing means that given a readable stream, we create two copies of it. Let's see why we might need to do that. I have this /teeing route. In that, I have the getTeeingStream method. I have a source array and I have different string values in it. I am creating a new readable stream and returning it. In that, we have the start method where I am adding each value from our source array into the readable stream queue. I am also waiting every 100 milliseconds to indicate an artificial delay. Let's suppose that extracting each element from our array is an expensive computation. In the real world, it might be something like processing a huge video file. So we get our stream and we want to do two things with it. First is that we want to log each chunk that we have, and second is that we want to send these chunks to our client. So here I am doing exactly that. I am getting the reader from the stream. I start reading the stream and I am console logging the chunk, and at the same time I am also sending the stream to the client. This is another way that we can pipe the response to the client. Here we are converting the web readable stream to a node readable stream and then using the pipe method on the node readable stream. So let's see what the response is in the browser. So we get an error. So the error is that invalid state readable stream is locked. We also see our console log values, but we are not able to see the chunks on the client. And the reason for that is with any given stream, we can only perform one particular process. The stream has its internal queue state, and considering our case, when we start reading the stream, we are iterating over that queue. We read the chunk, get rid of that chunk from the internal queue, and move on to the next chunk. So it's not possible to send the chunks sequentially again to the client as we have altered the queue state. Streams represent flow of data and not the source data itself. So if we want multiple flows, we need multiple streams. So that's where teeing comes in. It creates copies of a given stream, so we can process it multiple times. So let's uncomment this code and get rid of this. We create a debug stream for logging the chunks, and we create a response stream for sending it to the client by calling the tee method. And we'll replace the stream with the response stream. Let's see if we can get a response correctly now. So yeah, we see the chunks on the client as well as we see it on the console. Now let's look at the final example, that is transforming a stream. In this, we'll have an input readable stream of capital case alphabets from A to Z. Then we'll be using a transform stream to lowercase those alphabets. So let's see how we can do that. I have this /transforming route and this get transform stream. In this, as usual, we are creating a readable stream, and in the start method, firstly we enqueue an input string, and after that we iterate through 65 to 91, which are the UTF encodings or the ASCII encodings of the capital case alphabets, and we enqueue those individual characters. We don't need to use text encoder as we are directly adding the encoded values of the characters using the unsigned 8-bit integer array. Once the readable stream is created, we will copy that stream because we'll be using it for two purposes. We want to send the input stream to the client, and we also want to transform the stream. That's why we need to create copies. Let's first send the input stream that we have to the client, and we do that using the pipe2 method. So let's see if we see that in the browser. Yeah. So we do see the input stream correctly. Next is we want to transform the stream. For that we have the transform stream class, and just like the readable stream we have the start method. It is fired as soon as we create this particular object. So firstly we enqueue a output string chunk. Now the main method to look out for is this transform method, and it will be fired for every chunk that we have in our readable stream. In this method we'll be adding 32 to each chunk that we receive to lowercase it, and since each chunk is an unsigned 8-bit integer array itself, we need to call the map method on it. We also need to ignore the input string. We won't be transforming it, so we'll simply ignore it. Finally, once we are done transforming all the chunks from the readable stream, the flush method is called, where we terminate the controller. So when exactly is this transform method called? So we create a new readable stream by piping our original stream through this transform stream, and the transform method will be called when we start consuming this new transform readable stream. That is when we pipe our response to the client. So let's send this transform stream to the client by using the pipe to method again. Let's see if we see the response. Actually we don't see the output, and rather we get an error where it says destination writable stream is closed. And this happens because we are calling the pipe2 method twice, but the destination writable stream gets closed as soon as we finish piping the stream the first time. And we can prevent that by passing a prevent close parameter to indicate that we don't want to close the destination stream early. Let's see if we can see the response in the browser. Yeah. So this is how we can transform a readable stream. Thank you.